the lesson today, we'll be touching on what is speed of reaction. Different chemical reactions take place at different speeds.
For example, rusting of iron in air is a slow reaction. Browning of cut fruits is a moderately fast reaction. And the explosion of chemical is a very fast reaction.
In this video, we'll be discussing the factors affecting the speed of reaction. They are concentration, pressure, temperature, particle size, and catalyst. The effect of these factors on the speed of reaction can be explained by the effective collisions between reactant particles.
Before we look at the factors affecting the speed of reaction, let us first recall what is an effective collision. In this animation, the two cars represent two reacting particles. The conditions of effective collision are the reacting particles must collide head-on with each other to react. This is not a head-on collision, and thus no reaction occurs. The reacting particle must collide with a minimum amount of energy known as the activation energy.
Now that we have learned the concept of effective collision between reacting particles, we can use it to explain how the 5 factors mentioned earlier affect the speed of reaction. In other words, any factor that increases the frequency of effective collisions will also increase the speed of reaction.
The 5 factors which we will be learning are concentration, pressure, temperature, particle size, as well as the use of a catalyst.
The first factor that can increase the frequency of effective collisions is concentration. As you can see, at a lower concentration there is lesser reactant particles, while at a higher concentration there are significantly more reactant particles colliding into one another. So why does the speed of reaction increases at higher concentrations? At higher concentrations, there are more reactant particles per unit volume available to collide with each other. This increases the frequency of effective collisions and thus increases the speed of reaction.
The second factor is pressure. Note that this factor is only relevant for gaseous reactions. At lower pressure, the particles of gaseous reactants are spread far apart, while at higher pressure, the particles of gaseous reactants are closer together. Why does the speed of reaction increase at higher pressures? At higher pressures, the particles of gaseous reactants are closer together. Hence, there are more particles per unit volume of gas available to collide with each other. This increases the frequency of effective collisions and thus increases the speed of reaction.
The third factor is temperature. At lower temperatures, the reactant particles move slowly because they have little energy. When the temperature is increased, the reactant particles gain energy, move faster, and collide with each other more often. Why does the speed of reaction increase when the temperature of a reactant is increased? At higher temperatures, reactant particles move faster, resulting in an increased frequency of effective collision between particles. Likewise, an increase in temperature will result in more particles having the minimum activation energy when they collide, increasing the speed of reaction.
Let us summarize the key ideas we have discussed. An increase in concentration will result in an increase in the speed of reaction. An increase in pressure will result in an increase in the speed of reaction. An increase in temperature will result in an increase in the speed of reaction. Students, now that you have watched the video, do apply what you have learned on the worksheet and we will go through it in class tomorrow.